friends, in this video we are going to study the block diagram of cathode ray oscilloscope or CRO. So let us start with our topic. The cathode ray oscilloscope, also known as CRO, is one of the most flexible and versatile instrument. And also CRO is one of the prerequisite or the must present instrument in any of the electronics laboratory. The cathode ray oscilloscope or CRO, it is used to visualize, measure and analyze the different types of waveforms and other phenomena in electrical and electronic circuits. So what the CRO basically does, a basic CRO, it allows an individual to view and to plot the 2D graphs of different electronic signals. The electronic signals like voltage, current, acceleration, pressure, strain. The waveforms of all these electronic signals can be plotted and they can be analyzed with the help of CRO. So here if we define that what a CRO does, then so CRO is plotting a 2D graph of the electronic signals. So we can say that CRO is a XY plotter which is plotting the signal on the X and the Y axis. Now on the X axis we are having the amplitude of the input signal and on the Y axis we are having the time. So we can say that it is plotting an input signal versus time or versus any another signal. Okay. So when the waveform of an input signal is plotted on the CRO, it is displayed on the screen of the CRO. So we can analyze that waveform and can do different types of measurements, like we can measure the amplitude, we can measure the frequency, we can measure the phase difference between the two signals, the rise time, peak time, fall time. All these characteristics can be measured with the help of the CRO. So CRO is not only used for plotting and visualizing the waveforms, but also it is used to measure the different characteristics of the waveform. Now here we will study the block diagram of the cathode ray oscilloscope, and this block diagram, it shows the various functional units present in the CRO. So let's start with the block diagram. If we see a CRO, then this CRO consists of different sections, like it is having a display section, it is having vertical controls, horizontal controls and triggers. So we can say that if we draw the block diagram representing all these functional units, we can divide the block diagram into 4 sections. And these 4 sections are display section, vertical controllers, horizontal controllers and trigger section. Now all these four sections, they consist of various components. So if we see the block diagram of the cathode ray oscilloscope CRO, then these four sections on the CRO block diagram can be represented as, this is the block diagram of CRO. In this we are having different sections. This is our display section. Here we are having the vertical input, vertical amplifier. So these are the vertical controllers. Here we are having the horizontal controllers, and then we are having the trigger section. So here we are having vertical controllers. Here horizontal amplifier, sync amplifier, horizontal position. So these are the horizontal controllers. And here triggering is provided. So here we are having the trigger section. So these are the four sections in the block diagram. Now you can see that these sections, they consist of various components. First we will start with the display section. The display section is the main part of the CRO because the waveform of the input signal, that will be displayed in this section. Now the display section of CRO, it consists of CRT, that is cathode ray tube. The cathode ray tube, it is the main part, or we can say it is the heart of the CRO, because the waveform is displayed here with the help of the CRT or cathode ray tube. So let's study about the cathode ray tube. So in the display section, we were having the first or the main part, that is cathode ray tube or CRT. The cathode ray tube, it is a vacuum sealed glass envelope, okay, and in this glass envelope we are having an electron gun which is producing the beam of electrons. Then we are having the deflection plates. There are two pairs of deflection plates, horizontal deflection plates and vertical deflection plates. Then we are having the phosphor screen on which the beam of electrons strikes and produces a luminous spot, or we can say that the waveform of the input signal will be displayed on the phosphorus screen. So CRT also consists of various parts. It will have the electron gun, then it will have the glass envelope, deflection plates, and display screen. Now what the electron gun is doing, it is producing the beam of electrons. So in electron gun also we are having different parts. So let us understand this with the help of the diagram which is showing the internal structure of the cathode ray tube. Here you can see that the CRT, it consists of a glass envelope, and in this glass envelope we are having the electron gun, we are having the deflection plates, vertical deflection plates and horizontal deflection plates, and then we are having the phosphor screen. Now in the electron gun we are having a heater which is producing the electrons. This heater, it is heating the cathode, okay. Now cathode, it is having a layer of barium oxide over it. So when this cathode is heated, the electrons, that is barium oxide, it splits and valence electrons, they are released. These electrons then passes through the control grid. The control grid, it controls the number of electrons which are passing through it, okay. So if we want that more number of electrons should pass, we can increase the space between it. There is a hole in the control grid, so if we increase the space, so more number of electrons can pass through it, and if we want that less number of electrons should pass, so we are going to minimize the distance. So control grid controls the number of electrons passing through it. After that, the electrons passes through the pre-accelerating anode, accelerating anode and focusing anode. So the beam of electrons which is coming out, that beam of electrons will be accelerated and then it is focused. So the electrons, the beam of electron which is coming out of this electron gun, it will be a sharply focused accelerated beam of electrons. Okay. Now that beam of electrons, it passes through the deflection plates. First we are having the vertical deflection plates, and then we are having the horizontal deflection plates. So the vertical deflection plates is causes the electrons to move in the vertical direction, that is from up to down, and the horizontal deflection plates, it causes the electron beam to move from left to right. So left to right and up and down the electrons are moving. So whatever the deflection or whatever input signal we are applying, so according to that input signal, the movement or the deflection of the electron beam will take place. Now when this electron beam comes out, it is going to strike with the phosphorus screen. The phosphorus screen, it is having a coating of the phosphor element. So when the beam of electron, it is striking with the phosphor, so luminescence is produced, means a beam of light is produced. And then the luminous spot, that is going to move over the screen according to the variations in the input signal. So we can say that this CRT, because it is it is displaying the input signal, that is why it is the main part or the heart of the CRO. So here in the display section, we studied about the cathode ray tube, that is the CRT, and we see that the CRT, it consists of various parts: electron gun, glass envelope, deflection plates and screen. Electron gun, it also consists of the heater, cathode and the three types of anodes: pre-accelerating, accelerating and the focusing anode. Now again, coming back to the block diagram, you can see that all these parts of the display section, they are shown here. First we are having the heater here. Heater is there, then cathode, then control grid, then we are having the accelerating anodes and focusing anodes are there. After that we are having the deflection plates. So vertical deflection plates, they are causing the movement in the y-axis, in the y direction. So here y is written and it is attached with the vertical position. X, these horizontal deflection plates, they are connected with the horizontal position. So when we see the panel, that is the CRO. So on the CRO panel, we are having these knobs. So these knobs are used to change the vertical and the horizontal positions. So these are the controllers, vertical controller and the horizontal controller. After coming out the waveform, it will be displayed on this screen. Here we are having the screen. Okay. So that is about the display section of the CRO. Now coming to the vertical controllers. Now in the vertical controllers, to change the vertical position, we have these knobs for the vertical position. For changing, if we want the waveform to be in the center of the screen, so we can change the vertical position with the help of this knob which is present on the CRO panel. Now in this vertical controller, we are having the vertical amplifier. The function of this vertical amplifier is to amplify the input signal which is applied to it. Because the signal which we want to display, that is here the vertical input, and horizontal input, it is the internally generated ramp voltage which is called the time base. Because if we want to display the input signal with respect to time, so we have to apply a ramp voltage, so that the vertical input signal, it will be displayed with respect to the time. Okay, so here we will apply the input signal. So if we talk about the vertical section or vertical controllers, the first part is the vertical amplifier. So what this vertical amplifier is doing, it is just amplifying the input signal. Suppose that we are having the input signal with a very low frequency. So to increase its amplitude, we are applying the vertical amplifier. This amplifier only, that is going to amplify the signal. It is not going to distort the signal, or it is not going to amplify the noise in the signal. Okay, so it is just the amplification of the input signal. Okay, so just amplification is done here. Also here you can see that this vertical input, that is Y input, it is applied to vertical amplifier, and then it is given to the Y deflection plates. Okay, that is the vertical deflection plates is this provided. Now coming to the, if we want that directly without any amplification the signal should be applied, so vertical direct input is also available, and this input is applied after the amplification. Now coming to the horizontal controllers. In the horizontal controllers, again we are having the horizontal position. So if we want that, we want to alter the horizontal position of the waveform, that can be done with the help of this knob available on the panel of CRO. So in the horizontal position can be altered in this way. Now here also we are having a horizontal amplifier. So the horizontal input, it is provided to this horizontal amplifier. It will be amplified. After that it is given to the, you can see that if we want that directly the signal should be provided, we have here horizontal direct also, and if we want that after amplification it should be provided, if the horizontal signal is very weak, then we will amplify it and then it will be provided to the horizontal deflection plates. Okay, now in the horizontal controllers we are having a sync amplifier also and a sawtooth sweep generator also. So you can see that the sawtooth sweep generator, it is triggered by this synchronization amplifier. Okay, it is getting the input from this and it is providing an output which is used to trigger the horizontal amplifier. Okay, so what this, okay, so horizontal amplifier also amplify the weak signals. Now as I have said that the input signal which we want to display on the screen of the CRO, that will be applied to the vertical input, and the horizontal input, it is an internally generated ramp voltage which is also called the time base. Now how this ramp voltage is internally generated, we are having here a sawtooth sweep generator. The ramp voltage is also known as the sawtooth wave. Okay, voltage waveform is also called here a sawtooth wave. So sawtooth sweep generator, it is going to generate the time based signal, and then this time based signal, it is provided as an input to the horizontal amplifier. So if we want that, if we want to display two signals, then one will be provided to the vertical input and another will be provided to the horizontal input. If we want that an input signal is displayed with respect to time, then here the input, this switch, it will come here, it will be connected here, and an internally generated ramp voltage will be provided at the horizontal input so that the input signal can be plotted with respect to the time. Okay, so if we talk about the second part of the horizontal controller, we are having horizontal amplifier also, and we are having a sawtooth sweep generator also. Now what this sweep generator is doing, it is generating the ramp voltage, or we can say it is generating the time base, and Here, this sawtooth sweep generator, it is triggered by the synchronizing amplifier when this sync selector switch, it is at the internal position. When this, it is at internal position, okay, so this sync amplifier, it is going to trigger this sawtooth sweep generator. It is going to generate the ramp signal or the time base, and then this time base is provided as the input to the horizontal deflection plates, okay. So the whole functioning of sawtooth sweep generator is to generate the ramp voltage or time base by triggering with the synchronizing amplifier. When this synchronizing amplifier, it is at the internal position, it is going to trigger the sawtooth sweep generator, and this sawtooth is going to trigger the horizontal amplifier. Now this synchronizing amplifier, it is used for the synchronization purpose. Synchronization is very necessary between the vertical input and the horizontal input, so that both these so that the sweep generator, it is going to generate the sweep at the same time when this vertical amplifier vertical input is given to the vertical deflection plates. So when this vertical input is produced, at the same time the sweep is also has to be produced. So this synchronizing amplifier, it is providing the synchronization between the two inputs. Now this sweep generator, because it is providing the triggering input to the horizontal amplifier, so this triggering can be provided in various ways. So there are various types of sweeps generated. Let us study about these types of sweeps. There are four types of sweep. First is the free running, or recurrent sweep. Then we are having triggered sweep. So these are the four types of sweep which are generated by the sawtooth sweep generator. In the first free running or recurrent sweep, the second sweep is generated as soon as the first sweep is ended. Okay, so just after the first sweep, the second sweep will be immediately generated. So it is free running or recurrent sweep. The name itself suggests that recurrently or successively the sweeps are generated. Okay, then we are having triggered sweep. Triggered sweep, in that the sweep will be generated when the sweep generator, it will be triggered by some signal. Okay, then we are having driven sweep. In the driven sweep, the sweep will be generated when the sweep generator, it will be triggered by, or it will be driven by the input signal. Okay, now next is the non-sawtooth sweep. The non-sawtooth sweep is used in the cases when we want to use the CRO to find out the phase difference, or we want to measure the frequencies of two voltage signals. Okay, so these are the four types of sweep signals which are generated with the help of the sawtooth sweep generator. Okay, if we want that continuously the sweep will be generated, then we are going to use the free running or recurrent sweep. If we want that the sweep, if our input signal it is non-periodic, and we want that the sweep should be produced or triggered by the input signal, then we are going to use the triggered sweep. If the sweep is to be driven by the input signal, then this is the driven sweep. And if we want to compare the frequencies and to measure the phase difference, then we are going to use the non-sawtooth sweep. So this sweep generator, it provides these types of sweeps to the horizontal amplifier. Horizontal amplifier is going to amplify these this signal, and then it is going to provide this sweep signal to the horizontal deflection plates. So from the vertical input we are getting the inputs waveform or the input signal which we want to display, and from the horizontal input we are getting the sweep signal, okay, or we can say the time base. So the input signal, it will be plotted with respect to the time and it will be displayed on the display area of the CRO, okay. Now here we are having the synchronization amplifier. Because this Sawtooth seed generator, it is triggered by this synchronization amplifier. So what is the use of this amplifier? This amplifier provides the synchronization between the vertical input and the horizontal input. Because we want that the horizontal input, that is the sweep, it should be produced at the same time or this of this vertical input. Okay, so this here we are having a switch which is the sync selector switch. So there are three types of synchronization. Here we are having an internal synchronization, external synchronization, and line synchronization. So with the help of this selector switch we can choose any of these three types of synchronization, and this synchronization allows the input pattern to be stationary on the screen. Okay, if we want that our display waveform it is stationary on the screen, then this synchronization is necessary. So the next part of this horizontal controller is the synchronization amplifier. And this synchronization amplifier, it is provides the synchronization between the sweep and the input signal which we want to measure. Now there are three types of synchronization. First is the internal, second is external, and third is line. Now in the internal synchronization, you can see when this sync selector switch is at internal position, then this vertical input, it is connected to it. So we can say that synchronization is provided from the signal which we are measuring, because at the vertical input we are providing the input signal or the signal which we want to measure. So same signal is provided here for the synchronization. So in the internal, trigger is obtained from the signal which we want to measure. In the external synchronization, the trigger is obtained from an external source, and in the line synchronization, the trigger is obtained from the line frequency. You can see that in the line, it is connected to the line frequency. So from the power supply source, the synchronization is provided. So these are the three types of synchronizations done between the vertical input and the horizontal input by this synchronization amplifier. So this completes the vertical controllers, horizontal controllers. Triggering section is also there, that is external sync input, external synchronization input, and the display area is also covered in it. Now apart from these vertical and the horizontal controllers, there are other controllers also like intensity control, focus control, astigmatism, and blanking circuit is there, calibration circuit is there. So let's study about these remaining parts of the block diagram. First we will come to the intensity control. Now intensity of the display, on the display screen we are getting the luminous spot. Okay, so to increase the intensity of this spot, what we can do, we can increase the number of electrons coming out of the control grid. Okay, so you can see that this control grid, it is connected with the intensity control. Okay, so to increase the intensity of the spot on the screen, we are going to connect it with the control grid. Okay, and it is going to control the number of electrons which are passing through the control grid. So intensity modulation, we can say that changes in the intensity of the spot can be done by inserting a signal between the control grid and the cathode, so that the number of electrons passing through the control grid, that can be controlled. So we can say that intensity or brightness of the display spot, it can be controlled with the help of this by inserting a signal between the control grid and the cathode. Next control is the position control. You can see that for the for the position control, we are having two controls here: vertical control position and horizontal position. So if we want to modify the vertical position of the luminous spot or the horizontal position, it can be done with the help of these knobs which are available on the panel of the CRO. So next controller is the positioning control. And this controls the position, the vertical and the horizontal position of the display. Next comes the focus control. Here we are having intensity, focus and the position control. So focus control is, it can be done by changing the focal length, because here we are taking the focusing an anode. Here we are having the focusing anode, which is focusing the electron beam which is passing through it. So this focusing anode, it is acting as a lens. Okay, so if we want that the focus of the display is also changed, so with the help of this focus control, we can do that. Okay, next we are having the calibration circuit. Now, if we want to calibrate the CRO, we have to use a standard signal. Okay, so at the vertical input, we are providing the standard input signal, like we are providing a standard square waveform, and here horizontal input will be the internally generated ramp voltage. So that will be displayed over the display area, and with the help of that standard input, we can calibrate the circuit. Okay, so here we are having a calibration oscillator which is providing the standard square waveform, and this square waveform is provided to the vertical input. So as this square wave, the amplitude of this square wave is known to us. So this square wave can be used as a standard, and that will be provided as the vertical input to the CRO. Another circuit is the blanking circuit. Blanking circuit is useful when we want to eliminate the retrace which is produced when the spot is moving from right to left. Okay, so when the luminous spot, it is tracing the waveform, it is going to move from left to right in the horizontal direction. Now when the spot is moving from right to left, it is retracing the waveform. So to eliminate this retrace, the blanking circuit is used. So this retrace, it is going to produce a confusion. So to eliminate this retrace, the blanking circuit is used, and this blanking circuit, it is getting the input, the blanking voltage, it is produced by this sweep generator. So you can see that Sawtooth sweep generator, it is giving the input to the blanking circuit, and this blanking circuit is providing the input to the CRT. Okay, so this CRT screen, it is going to eliminate the retrace so that no confusion is produced. Apart from this, also we are having here an astigmatism control. So by adjusting the focus here, by adjusting this focus of this focusing anode, we can remove or we can avoid the problem of astigmatism in the CRO. Okay. So in this block diagram, we studied that there are various sections, like we are having the display section, which consists of the cathode ray tube, which is producing or displaying the input waveform. Then we are having the vertical controllers and horizontal controllers, which included the vertical amplifier, horizontal amplifier, sawtooth sweep generator, and synchronization amplifier. In the triggering part, we are having the triggering, which is done like how the various types of sweeps are generated and what are the various types of synchronization between the vertical input and the horizontal input. After that, we studied some external controllers like the intensity control, focus control, astigmatism, blanking circuit, and the calibration circuit. So that covers the complete block diagram of the cathode ray oscilloscope or CRO. So I hope that this topic is now clear to you. Thank you.